This video, we're going to go over this AP released test question from 2007, talk about what the method is and why. Investigators at the U.S. Department of Agriculture wished to compare methods of determining the level of E. coli bacteria contamination in beef. Two different methods, A and B, of determining the level of contamination were used on each of 10 randomly selected specimens of a certain type of beef. The data obtained in millimicrobes per liter of ground beef for each of the methods are shown in the table below. Is there a significant difference in the mean amount of E. coli bacteria detected by the two methods for this type of beef? So what you're seeing is there was 10 pieces of beef and they did method A and method B on this. Okay, so this is what's going to be a matched pairs t-test. Okay, because this is one piece of beef, they did method A, they got 22.7, they did method B, they got 23. So they're comparing the method, and it said there was 10 pieces of beef. So this is matched pairs. So we have to read the problem and analyze it when it looks like it could be either the two sample or the matched pairs, and you have to really think about it. Is each of these independent groups? And that is not true. So it's a paired data. So we want to determine the true mean amount of E. coli bacteria detected by the two methods. And we're going to set an alpha of 0.05 because it doesn't tell us anything else. And our H naught is that the mean difference is equal to 0. And our alternative, because it just says, is there a significant difference, is going to be that mu difference is not equal to 0. So we're going to put this data in our calculator. We're going to put method A in list 1 and method B in list 2. So I have the data right there. Here it is in my calculator. And then I'm going to scroll up, highlight list 3, and I'm going to do second L1 minus, so I can't see, second L2. Okay, so notice that that's up on the screen here. I've highlighted L3, and then I tell it to do L1 minus L2, and then when I hit enter, it's going to give me all of those differences. Okay, then I go to stat calc, one of our stats, and I'm going to do one of our stats on list 3. Keep your frequency list empty. And there is our statistics. Okay, so we have a mean difference. So X bar, these are our statistics. X bar of the difference is 0.29. I have S of the difference is 0.629. 97, so we're going to round that to 6.3, and then N of the number of differences is 10. So there is the statistics, and now let's check our conditions. So conditions, right? Choose, that was our choose step. This is conditions, check conditions. The sample was random. Let's see where it says at 10 randomly selected specimens. So the sample was random. So we can generalize. Ten is less than 10% of all pieces of beef. So we can sample without replacement. And then we don't have n greater than 30, so we're going to have to go back to our calculator. Okay. So in the calculator, there we go. We're going to go second stat plot. And I already have it on. I already have it selecting that histogram and L3. That's where my differences are. I'm going to zoom 9. Okay, and there is my histogram. So that shows no strong skew or outliers. So it's nice and symmetric. So the histogram of the data shows no strong skew or outliers. So we can use a normal model. So our conditions are met. Now we can do our test. Our general formula, remember, now we don't actually have to write this down, but just a reminder, is the statistic minus what we hypothesized. So the parameter is what we hypothesized over the standard deviation, okay? And so in this case, it's x bar difference divided by the standard deviation of the difference, well, minus 0, divided by the square root of n difference, which is 0.29 divided by 0.63 over the square root of 10. So that is my t. Now once again, we're going to go to our calculator. And I can do that calculation in here, or I can go into my tests. I'm trying to find the right angle. I'm going to go into stat tests, just so I can show you this as well. T-test. And I have my data. My null hypothesis is 0. No, that's not a 0. And my data is in list 3. Hold on. All right, here you go. I got list 3 in there. And then we said our alternative was not equal to. I know the glare's killing me here. And then we're going to go down to calculate. And it's going to tell me the t is 1.45 and the p is 0.179. Okay, so we're going to write that down. Okay. Now if we do the calculation in the calculator, we should be getting the same exact thing. So the nice thing about knowing the calculator commands now is once you plug it in to the formula, you have the numbers plugged in, then let the calculator do the hard work for us. So our test statistic, remember, is our t-value, which in this case is 1.456, and our p-value is 0.179. And the calculator already multiplies it by 2. Now, if you're doing this by hand and you do 0.02 or 0.29 divided by 0.63 divided by the square root of 10, I need to put this standard deviation in parentheses. So I'm going to show you that in a picture in a minute. And then I'm going to do TCDF. Okay, so then you would do this. It's going to give you 1.456. And then I'm going to do TCDF. 1.456, 99, 9 degrees of freedom. And here's what it looks like plugged into the calculator using TCDF. Notice I get the same thing that I got when I did it up here, right? My T and my P out of the calculator. There's my T, and I have to multiply the TCDF by 2 because of a not equal to hypothesis. So the nice thing, calculator does that part for you. Now we're going to write our conclusions. I'm going to actually pause it, type it, and then let it come on the screen. So take a second, pause it, and write out your conclusion and your interpreting of your p-value. Okay, so here is our p-value and conclusion. I figured I'd type it since my handwriting is starting to get bad. Assuming HO is true, there's no difference in the E. coli detected for method A and B. That's our null hypothesis. There's no difference. This adds context to our p-value, so it's good to kind of do that, especially with these differences. There is a 0.179 chance of getting our sample mean difference of 0.29 or more extreme purely by chance. In our conclusion, because our p-value of 0.179 is greater than our alpha of 0.05, we failed to reject HO. There is not enough evidence to convince us there is a significant difference in the mean E. coli detected for method A and method B.